My dear students, welcome. We'll speak today about the electromotive force after estimating standard potentials of many measured half cells relative to the standard hydrogen electrode or the standard hydrogen potential. These potentials were arranged in a series known as electromotive series. So what is the electromotive series? Its concept is very important in chemistry. So it is the arrangement of elements descendingly according to their activity. Means the higher elements is the more active elements. Means lithium is more active than potassium, and potassium more active than calcium. Sodium is more active than magnesium, and so on. So the higher elements is more active than the lower elements. So it is the arrangement of elements descendingly according to their activity. So the more active element in the higher places, the less active element in the lower places. Okay, what is the difference between the higher elements and the lower elements? The higher elements here, like lithium, has higher oxidation potential. Higher oxidation potential means the easy to release electron, the strength to easy electron is positive 3.045, which is the most stronger or the highest value of the oxidation potentials of elements. So it is the ability to release electron, the ability to lose electron to another element, so it reduces another element. So as the oxidation potential increases, so the ability to reduce other elements increases. So lithium has the highest oxidation potential, so its ability to give electrons to another element is very strong. So it is a reducing agent or a powerful reducing agent. It is more powerful than potassium, as potassium the oxidation potential is very high but not higher than the lithium. So lithium is more a reducing agent or has more strength to lose electron and to give other elements electrons more than potassium, as the value of lithium as an oxidation standard oxidation potential is higher than that of potassium. So we can make a definition of the electromotive series as this is the arrangement of elements descendingly according to their oxidation potential. So the oxidation potential of the highest element of the higher element is positive or high, and descendingly with the elements in the electromotive series. So the lower elements has less oxidation potential than the higher. Okay, and there is the hydrogen separates from the positive and negative oxidation and reduction. So lower than hydrogen, the oxidation potential is negative. This element cannot release electrons but accept electrons, so the reduction potential is higher. So as we go down the series, the ability to be reduced, the ability for the element atom to accept electrons or to be reduced is higher. So the electromotive series is the arrangement of elements descendingly according to their oxidation potential or ascendingly according to the reduction potential. When you look at the point of view or from the point of reduction potential, lithium, for example, its standard reduction potential equals minus 3.045. It is the lowest reduction potential because minus here means hating, not accepting electron but releasing electron. So as the reduction potential decreases, so the reducing effect of this element increase. So the lowest element in the electromotive series in the value of reduction potential, standard reduction potential, is lithium, and it is the strong reducing agent. So element in the higher position replace elements in the lower position in their salt solution, and especially those who are higher than hydrogen. They replace hydrogen in acids and replace hydrogen in water. We have some notices about this electromotive series. Look, the elements of the first and second groups are the most active elements with the higher oxidation potentials, and element of the transition elements, metals, they are lower in this series. So lithium, potassium, calcium, sodium, magnesium is higher, and aluminum also higher in the have higher positions in the electromotive series. Transition elements like manganese, zinc, chromium, iron, cadmium, cobalt, nickel, tin, and lead is still higher than hydrogen. Their oxidation potential is still positive, and the reduction potential is negative. We have to mention something after hydrogen. After hydrogen, the arrangement of elements who are less active than hydrogen. So these elements cannot replace hydrogen in water or replace hydrogen in acids. The most the famous elements in the levels lower than hydrogen are the coinage element, like copper, silver, platinum, gold. They are less than hydrogen, so their oxidation potential is negative, and they have high reduction potential. They are able to be easily able to accept electrons from other elements in the higher positions. Okay, so how can we memorize it? The elements with higher oxidation potential, the more active elements, are those of the first and second groups in the periodic table: lithium, potassium, calcium, sodium, magnesium, and also aluminum. Some transition elements, they are more active than hydrogen, although less active than the first metals, the metals of 1A or 2A and 2A groups, like manganese, zinc, chromium, iron, cadmium, cobalt, nickel, tin, and lead. Between them there is hydrogen. After hydrogen, we know that, or we have to notice that the coinage elements or the coinage metals are less in activity than hydrogen, so they cannot replace hydrogen in their salt or in water or acids. The most famous coinage metals: copper, silver, platinum, and gold. They are less active than hydrogen. They cannot replace hydrogen either in water or in acids. Hydroxide ions more able to be reduced, more easily to be reduced. They accept the electrons, oxygen to water molecule, 4 electrons give 4 hydroxide ions. So they are easy to be reduced than hydrogen. So also the halogen elements, halogens are less active than hydrogen, and they are in the lower places than hydrogen. Halogen like iodine, bromine, and chlorine, and fluorine. Chlorine, bromine, iodine is lower in activity than hydrogen. Now again, the electromotive series. What is the electromotive series? It is the arrangement of elements descendingly according to their oxidation potential. So the higher oxidation potential elements lie in the upper places, and the lower oxidation potential elements lie in the lower places of these electrochemical series or electromotive series. It can be expressed in another way. It is the arrangement of elements according to the reduction potential ascendingly. So the lower reduction potential elements lie in the top of these electromotive series, and the lower elements has higher reduction potential. We have to know that the elements which lie in the group 1A and 2A in the periodic table, like lithium, potassium, calcium, sodium, magnesium, and group 3 also, the more active elements and metals, they have the highest oxidation potential in the electrochemical series. Afterward, the transition element like manganese, zinc, chromium, iron, cadmium, cobalt, nickel, tin, and lead. We have to notice that the hydrogen is a standard. Its oxidation and reduction potential equals 0. So below hydrogen there are elements characterized by their reduction potential is high. As we go down, the reduction potential increases, and their oxidation potential is very low, and as we go down, the oxidation potential decrease. So another time, the electromotive force is the arrangement of elements descendingly according to their oxidation potential and ascendingly according to the reduction potential. There is some notices about that. Through the studying of electromotive series, elements lie above the hydrogen are characterized by the following. The reduction potentials are very low, negative, and their oxidation potentials are positive. Easily to be oxidized, release electrons. They lose their valence electrons easily when they react with ions of any elements in the lower position in the series. They are a strong reducing agent, as they are more strong in giving their electrons to another elements. The strength of the reducing agent increase by increasing its oxidation potential. Oxidation potential means the powerfulness, the strength of this element to release electron to another element or act as a reducing agent. Elements lie below the hydrogen. The reduction potentials are positive or high, oxidation potentials are negative, easily to be reduced, accept electrons from other elements. They are a strong oxidizing agent, as they accept electron, they take electron from another elements and oxidize another element. So they are considered as an oxidizing agents. The strength of oxidizing agent increase as the reduction potential increase. Reduction potential means the ability of the element to take electrons. So the ability to take electrons is the ability to oxidize another element. So the oxidizing agent reduced and the reducing agent oxidized. Look at this. From the elements which lie at the top of the electromotive series, lithium, its oxidation potential is positive 3.0445 volts, and sodium, its oxidation potential equals positive 2.714 volt. So the oxidation potential of sodium is less than the oxidation potential of lithium. So lithium is more stronger reducing agent. It has more strength to give electrons to other elements, so it is stronger as a reducing agent than sodium. On the other hand, fluorine is reduced into fluoride its reduction potential is positive 2.87, and the reduction potential of chlorine into chloride equals positive 1.36. The value of fluorine as a reduction potential is higher than the reduction potential of chlorine in value. So it has more ability to accept electrons than fluorine. Accepting electrons means an oxidizing agent. It accepts electron from another element and oxidizing another element. So it is an oxidizing agent. So as the reduction potential increases, its ability to oxidize other elements increases. So in the top of the elements which are oxidized easily and be strong reducing agents, lithium oxidized easily because its oxidation potential is high, so it gives the electron to other elements, so it is the strongest reducing agent. Hydrogen here lie in between, its oxidation reduction potential equals 0. The more element to accept electrons, the more element which has the strong ability or the strength of it is very high in accepting electrons. Accepting electrons means its reduction potential is very high. So accepting electrons from other elements mean oxidizing another element, is fluorine, as it is the highest in the reduction potential. So it is the strongest oxidizing agent. The elements that lie at the top of the series replace those which follow them in their solutions. It is very important and critical point. The elements lie above in the series replaces those who are in the bottom of the electromotive series or in the lower places in the electromotive series. So zinc is higher than iron, iron is higher than copper. So zinc and iron can replace copper in their salt, in the salt of copper. Look at this. Zinc with copper sulfate, zinc replaces copper and forms zinc sulfate and copper precipitate. Iron and copper sulfate, the same. Iron is more active, its oxidation potential is very high or higher than copper, so it can replace copper in its salt solution. It makes ferrous sulfate and copper precipitated. When we look at this equation, copper cannot replace ferrous or iron in its salt, so no spontaneous reaction occurs. Also, we will notice that the ability of the element which lie above to replace the following elements increases by increasing the distance between them in the series. So zinc can replace copper, zinc can replace copper, iron can replace copper, but the ability of zinc to replace copper is more strong than the ability of iron to replace copper, as zinc lie more higher than iron in the electromotive series. Okay, some application about this. Iron, its oxidation potential positive 0.44 volt. Oxidation potential of copper equals negative or minus 0.34 volt, and that of hydrogen is 0. So iron can replace hydrogen as its oxidation potential is positive. Copper cannot replace hydrogen as its oxidation potential is negative. Hydrogen, sure, oxidation reduction potential negative, 0 equals 0. Okay, so iron replaces hydrogen ions in the hydrochloric acid. Iron, as we see in the above, positive oxidation potential positive 0.44 volts, so it is more active than hydrogen. It replaces hydrogen in acid and water, so it forms ferrous chloride and hydrogen gas evolves. Copper cannot replace hydrogen either in water or diluted acids, while sodium can replace hydrogen in both water and dilute acids. How can this happen? Because the oxidation potential of copper is lower than that of hydrogen, while the oxidation potential of sodium is higher. Sodium are more liable to release electron, as its oxidation potential is higher than that of hydrogen. But copper not. Hydrogen is more active than copper, and copper has lower oxidation potential than hydrogen. At this point, we will finish. Keep with us. We will explain all the curriculum and we will answer all the questions.